Now, today we are going to study the chapter called coordinate geometry. Now, the coordinate geometry, the basic concept you have studied in the class 9. Now, suppose a point is given and you want to represent it. If a point is just a whole number or an integer, it can be represented on a number line. But if a ordered pair is given to you, suppose if I say P 2, 3, it is an ordered pair. If you want to represent, then you have to represent it in a coordinate plane. Now, if 2 points are given and you want to find out the distance between these 2 points. So today we are going to study how we will find out the distance between the 2 points. First of all, just we will see that this is a coordinate plane, Cartesian or coordinate plane you can say, horizontal axis, x-axis, vertical y-axis. Now I am taking 2 points P and Q. You already know that the perpendicular distance on the x-axis is called ordinate, and the perpendicular distance on the y-axis, it is called abscissa. Now, if I am taking a point P whose coordinates are x1, y1 and the point Q whose coordinates are x2, y2, I want to find out the distance between this point P and Q. So, draw the perpendicular PA on x-axis, QB on y-axis. Now the same way I am drawing this perpendicular on y-axis. Now, you know that this is the distance, that is x1, because the coordinate here it is x1. So exercise x1, here again on x-axis, it is this distance is x2 from here to here. Now we come to the y-axis, here it is y1. So this distance will become your y1. Clear? Now when we come to this point, here this distance, that is same, it will become y2. Now when I am joining this here, it is becoming a right triangle. See, it's becoming a right triangle. So when I am saying in triangle PCQ, triangle PCQ, angle C is 90. Angle C becomes 90. Now here you can easily apply Pythagoras, but you may be thinking then what is QC? See, this is y2, this is y1. So your QC will become y2 minus y1. y2 minus y1. This will become QC. And now what is your PC? This is the whole, it is x2. This is x1. So this will become x2 minus x1. The PC distance will become x2 minus x1. Now, I can, because it is a right angle triangle, I can easily apply Pythagoras. So, we will go for a Pythagoras. In triangle PCQ, PQ square is equal to QC square plus PC square. Now, we have already seen that what is your PC square? x2 minus x1. PQ is equal to x2 minus x1 square plus what is your QC square? y2 minus y1 square. So you got, so this distance is x2 minus x1 and then this distance is y2 minus y1. So we have placed in the Pythagoras. Now, so this is your PQ square. Now square will go and become square root. Therefore, distance PQ is equal to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is your distance find out the distance, that is PQ, distance PQ is equal to square became square root x2 minus x1 the whole square plus y2 minus y1 the whole square. So this was your distance. Now suppose if I say I want to take a point, I want to find out the distance from the origin. Suppose if I am taking this as a P and the coordinates of this are x and y. I want to find out the distance of P. So it's very easy, you can put distance O. You can take another point. Suppose if I am taking R, then distance OR. Now the coordinates of O are 0, 0. It is from origin. If you want to find out the distance from the origin, so we can write distance of a point from origin. From origin. It will become distance OR is equal to under root. Now x2 minus x1. So it becomes 0. So you can say x minus 0 the whole square, x minus 0 the whole square plus y minus 0 the whole square, y minus 0 the whole square. So your formula comes up as under root x square plus y square. So this is a distance of a point from the origin. This is the distance of a point from origin. You can easily place it in the distance formula. Here your x minus 0 the whole square plus y minus 0 the whole square. So you are getting x square plus y square. So we have seen two formula. One is your distance formula and the next is the formula for a point, distance of a point between the origin. Okay? Your distance OR, that is a point lying in a coordinate plane and its distance from the origin, can be given by square root sine x square plus y square. Now based on this, okay, now this distance formula we have to keep certain points. You have to keep in mind that first it is some useful point in order to prove the given figure. If you want to prove a square is given to you, or you can say the coordinates of the points A, B, C, D of a, it is given, then you want to prove it is a square. How will you prove it? You have to prove all the four sides as equal by distance formula. You have to apply the distance in AB, BC, CD and AD. If all the distances are coming same and the diagonals also cross, AC and BD should also come same, then you can say that it is a square. If all sides are only equal, diagonals are not equal, then you can say it is a rhombus. If in a rectangle, if they have asked you to prove it is a rectangle, then only pair of opposite sides are equal and even diagonals are equal. You have to prove two things. Opposite sides are equal and diagonals are equal. If you want to prove it is a parallelogram, then only you have to prove that opposite sides are equal. Now, the next it is collinear. Now, collinear means the points which are lying in the same line. If the points which are lying in the same line, suppose if it is AB, BC, these are there, then we don't know whether B is lying in between A and C or not, or whether C is lying between A and B, we don't know. So what we have to do, you have to find out prove that sum of the distances between two pair of points is equal to the third. That is, you can say that AB plus BC is same as AC, or AC plus AB is same as BC, or BC plus AC is same as AB. Either of this can be true. Either of this will be true. Then only you can say that the points are collinear. If none of them are true, then the points are non-collinear. Now we come to here. Find the distance between the point P minus 6, 7 and Q minus 1, 5. So you have to just find the distance formula. So distance PQ is equal to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. First of all, write the formula. Now this, suppose this is your, you can say this is your x1 y1, this is your x2 y2. You can, these are the PK coordinate, x1 y1, q coordinate. Now you can replace the value under root. That will become minus 6 plus 5 the whole square plus 7 minus 5 the whole square. That is equal to under root, that will become minus 1 square plus 7 minus 5, that is 2 square. Clear? That will become 7 minus 5 will become 2 square. So first of all, this is your minus 6, minus of minus will become plus 1, minus 6 plus 1, so it will become minus 5 square, and that will become 7 minus 5 to 2 square. So that will be equal to, see again I am repeating, this is your minus 6 plus 1 square. This is 7 minus 5 square. Minus 6 plus 1 minus 5 square. 7 minus 5 2 square. So that will become 25 plus 4 under root 29. That will be clear. Now we come to the next question. Find the value of x if the distance between point x minus 1, 3, 2 is 5. Now suppose if I am taking like the coordinates of AB x minus 1 and coordinates of BB 3, 2. Okay? 3, 2. Now this is the coordinate. Now the distance is already given. The distance is given 5. Now distance AB, formula you have to write down under root x2 minus x1 the whole square plus y2 minus y1 the whole square. So now we can distance, you know, the distance is what? 5. So 5 is equal to under root x minus 3 the whole square plus minus 1 minus 2 the whole square. Now square will become square root. So you can write 25 is equal to x square minus 6x plus 9 and minus 3 square will become 9. Minus 3 का square 9. So this will become x 9, 9, 18 and 25 minus 18 is 7. So your equation will become x square minus 6x and 25, that will be minus 6x, 9 plus 9, 18. 18 minus 25 will become minus 7. Minus 7 is equal to 0. Now the factors of this, 7 and 1 can become, so we will write down x plus 1 and x minus 7 equal to 0. Factors you know, splitting middle term, 7 and 1. Therefore, x is equal to minus 1. So these are the, and x is equal to 7. X is equal to 7. But this value if you put, it will be ignored because the distance won't come out. So your answer will be x is equal to minus 1 for the distance 5. Now the next, find the points on x-axis which is equidistant from, now see, you should know that this is a point A, the coordinates of A are 2 minus 5, clear? And the coordinates of B are minus 2, 9. These are the coordinates. Now there is a point P. You are not to say that it is a midpoint. The point P is there, whose coordinate I am taking it as x, y. It is equidistant. The distance is same. This distance is same. So, and the point is x-axis. x's. So the x coordinate is there, but y will become 0. So you will write this as 0. Understood? If it is saying the point is lying on y-axis, then the coordinate of point will become, p will become 0, y. Because the point is lying on y. Here the point is lying on x. Now we will apply, as it is equidistant, pa square is equal to pb square. Pa square is equal to pb square. So x minus 2 whole square is equal, x minus 2 whole square is equal to plus 0 minus will become plus 5 square is equal to. So distance formula, x minus 2 the whole square plus 0 minus plus 5 the whole square will be equal to x plus 2 the whole square plus 0 minus 9 the whole square. So both the sides we have applied distance formula. Now you can apply the identity. X square minus 4x plus 4 plus 25 is equal to x square plus 4x plus 4 plus 81. Now x square cancels, 4 also cancels. So you will get minus 8x is equal to 56. Therefore, x is equal to minus 7. Hence the coordinate of point P will become minus 7, 0. The coordinate of P will become minus 7,